Hi, I am Yasar Arafath. I am here with another maths video for class 10 CBSE students. I welcome all of you to this video. Trigonometry. Welcome back to my YouTube channel. Up to this time, we discussed only simple questions in applications of trigonometry chapter. We discussed problems with a single triangle. But in this lesson onwards, we are going to discuss some problems having two right triangles in same question. If you didn't watch those previous videos, you can get those videos from the link in the description. I have given link to the playlist of chapter 9 Some Applications of Trigonometry in the description. If you are watching my videos first time, please subscribe my channel. If you like my videos, don't forget to press the like button and also share this video to your friends. Let's start the video. So today we'll discuss not simple question like previous questions, but not tough. So here in all questions we discussed today, there will be two right triangles. So two things are important. One thing is how to draw the picture. If you made a mistake, then you are not going to get correct answer. So you have to be very concentrated when you draw the picture. Okay. And one more thing, when you draw a 45-degree angle, 30-degree angle, 60-degree angle, you should have some imagination. How much should come? Suppose you are drawing a 45-degree angle. Suppose it is said that at top of a tree is seeing at a angle of elevation of 45 degree. So do you draw like this? Suppose do you draw like this? This is 45. No, right? So we know how much will look like a 45-degree angle and 30-degree angle, 60-degree angle. 45-degree angle we know that is the half of a right angle. A right angle we can draw rough, right? So 45-degree angle is just half of a right angle. So you should have some imagination when you draw a 45-degree. And similarly, in other terms, we can say the 45-degree angles, the triangles formed by 45-degree angles will be half of a square, right? Half of a square. So you should imagine with a square. So whether my angle is almost perfect or we are drawing rough figure, anyhow you should have some imagination. Otherwise there will be some problem when two triangles are coming. Okay, and the 30, 60, 90-degree angle triangle are the half of a equilateral triangle, right? So you should have some imagination. 60 will look like this much and 30 will look like this much. Okay, so if you get a question seeing the top of a tree at a 30-degree elevation, so you should draw almost like this. Okay, so we start the question. I shall bring here. For example number 4, I will start with this question. Okay, question is like this. From a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degree. A flag is hoisted at the top of the building and the angle of elevation of the top of the flagstaff from P is 45 degree. Find the length of the flagstaff and the distance of the building from the point P. Okay, this is the question. Okay, there's a building. I simply take one line. That is enough actually. And on the top of the building, there is a flagstaff. Okay, flagstaff. Okay, flag. Actually, no need to draw flag. Flagstaff. Okay. Then what is given? From a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degree. From a point on the floor, we can call it as P. To where we are looking, to the top of a 10-meter tall building is 30 degree. A flag is hoisted at the top of the building and the Angle of elevation of the top of the flagstaff from P is 45 degree. Okay, so if we are looking from some point P to the top of the building, so I have taken building as AB and the flagstaff as BC. Okay, and suppose P here, I put P, I know, I imagine if from here if I join to B, I will get almost 30-degree angle. That's why I put P here. So we should have some imagination. Don't put a P here, because if you put P here, if you join with a P, you are not going to get around 30-degree. That's wrong. So I made some imagination. If I put P here, so when I join with B, I will get almost a 30-degree angle. Okay, there is no observer, no mentioning about observer. So we take the elevation with the ground, the line of sight, and horizontal is ground itself here. If there is no mentioning about the observer, so horizontal, the angle of elevation is the angle made between the horizontal and the line of sight. In this case, we are looking from the point P. So the position of the eye is in the ground itself, from P itself. Okay, so the angle of elevation will be the angle between the horizontal and line of sight. Horizontal is the ground itself. Okay, so this will come 30-degree. This is the first statement. From a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30-degree. So AB, the length AB is given that 10 meter. Okay, then we want to put some other point from P. If we look to the top of the flagstaff from this point, we will get the angle of elevation will be 45-degree. So there's some wrong in my picture. So the flagstaff we want to extend a little more. So otherwise we won't get a 45-degree angle. Okay, from P, if you look to the top of the flagstaff, it is said that you will get a 45-degree elevation, from 45-degree elevation. So this total angle, this big angle is given that 45-degree. Okay, and this is the flagstaff BC. Okay, and what is the question now? Question is to find the length of the flagstaff and the distance of the building from the point P. We want to find two things. BC, this length we want to find out. BC is equal to, we want to find, and AP, the distance from the building to the point P, we want to find out. Okay, so two right triangles are there. So from each right triangles, we can apply the trigonometric ratios, and we can form two equations, and from those equations we can solve for the variables. Okay, so here BC you can take with the single letters, or simply taking BC, no problem. I think I better take X and Y. Suppose X is the height of the flagstaff and Y is the distance from the building to the point P. Okay, so we have two right triangles. From each right triangle we will apply the trigonometric ratios, suitable ratios, and we will form some equation, and we know how to solve linear equations in two variables, and we will solve that. Okay, so first we can choose this triangle ABP in right triangle ABP. So which is, we want to find Y given that AB. So which trigonometric ratio we want to take? The 30 degrees.
Tan 30.
Yes, tan 30. So tan 30 is equal to, how will come? Tan 30 is equal to
AB by AP.
1 by 3.
AB
1 by root 3.
Okay, AB by AP we can write in first step. Okay, or we can write a 10. Okay, next step enough. What is tan 30, the value? Tan 30?
1 by root 3.
1 by root 3 is correct. Okay, is equal to AB is given that 10 meter. So 10 meter divided, 10 enough. Okay, 10 divided by AP we have taken as Y. Okay, so I put Y here. So from this, what will be Y?
10 root 3.
10 root 3.
10 root 3, right? Y is equal to 10 root 3. You can apply number 1. Okay. So you take next to right triangle. What is the name next to right triangle?
ACP.
Okay, PAC or ACP or something. Okay, I write PAC. Okay. So here angle is 45. Don't confuse with this angle. This large angle, the horizontal with the line of sight from P to C. That angle of elevation is given that 45 degree. Okay. So this will make a 45, 45, 90 degree triangle, right? Okay. So look here, we have the opposite side. What's the opposite side of angle P in this triangle? AC, right?
AC.
That we can take as 10 plus x. P and AC are equal. Also, you can write this will be also equal to y. Okay. So anyhow, we will apply trigonometry ratio. So tan 45 is equal to 1. Okay. So use name, side names AC by
AC by AP.
AC by AP.
AP. So tan 45 is equal to 1. AC is x plus 10 and AP is y.
3.
AP is y. First step you can write y. So from this what will we get? Y is equal to
X plus 10.
Y is equal to x plus 10. And we combine 1 and 2 or we substitute 1. Okay, we substitute 1 or combining 1 and 2 or from 1 and 2. What will you get?
10 root
10
3.
root 3 is equal to h plus 10.
Yes, 10 root 3 is equal to x plus 10. This is also some idea of solving pairs of linear equations. Okay, so here directly we can apply this y value in the second equation. We will get the solution. In some case, you will get x and y in both equations. I think in the next question itself. Okay, so what will be x?
10 root 3 minus 10.
10 root 3 minus 10. So that is
Common.
we can take a 10 common outside. So 10 into
Root 3 minus 1.
root 3 minus 1. We can give approximate value. So that's given here.
1.732 minus 1.
Yes. 10 into 1.732 minus 1. So that will be
732.
0.732. Okay. So multiplying by 10, a decimal number. What's the idea?
7.32.
Yes, when we multiply a decimal number by 10, you want to shift the point, move the point one place to right. So this will be 7.32 meter. So the height of the flagstaff, we got height of the flagstaff as 7.32 meter. So one more thing is asked. Okay, I shall explain this. Okay, so combining from 1 and 2, equation 1 and 2, we got 10 root 3 is equal to x plus 10, right? Okay, because both are equal to y, so they must be equal. So next step, we can move this 10 to left side, so that will become 10 root 3 minus 10. X is equal to 10 root 3 minus 10. In next step, we are taking 10 common outside the bracket because in each term there is 10. So when we take outside the bracket 10, inside the bracket you want to divide each term by 10. So 10 root 3 by 10, you will get root 3. 10 by 10, we will get 1. Okay, you just think the reverse step. You will get this one. 10 into root 3, 10 root 3. 10 into 1, 10. Okay, and in the next step, we are giving the approximate value that is given in the question. Root 3 is equal to 1.732 approximate. Okay, so that value we apply here. Root 3 is 1.732 minus 1. If you subtract 1 from 1.732, we'll get to 0.732. Okay, then multiplying by 10, we want to move this point one place to right. So we'll get to 7.32 meter. Okay, we finished half of first sub question. Second sub question is to find the distance of the point P from the building. That is AP. What is AP?
Y.
Y. Okay, Y is AP. Okay, Y here itself we have. Right? Yes, yes. This is the distance. Okay, we have written here So simply write here, you want to give some conclusion in the end. The distance AP is 10 root 3. If you give the approximate value, can you tell what will be the value y? If you give the approximate value root 3.
7.32.
17.32.
Yes. Okay, so this will be 17.32. 17.32 meter, and the height of the flagstaff is 7.32 meter. Okay, give some conclusion in the end. Okay, we finish the question. So drawing the picture is very important. If you made a single mistake, then the time will be waste. Okay, in the textbook, the picture is given like this. The question we have discussed now: a building, and on the top of the building there is a flagstaff, and it is said the angle of elevation from point P to the top of the building is 30 degree, and to the top of the flagstaff is 45 degree. And give some name and do trigonometric ratios. Okay.